In this video, we're going to talk about a specific type of chemical reaction that occurs between acids and bases. And these reactions are called neutralization reactions. And you might be able to break it down or remember, these in general end up making a reaction have a pH that is neutral. However, that is not always the case. In fact, it's not going to be that often of the case in going forward. But remember, the general form is we take an acid plus a base, they react, and we're going to make water and a salt. Okay? However, now that we know about strong acids and strong bases, you're not always just going to make water and a salt. You might have some leftover acid or some leftover base. And from there, we can calculate things like pH and pOH and connect it to Kas and all this other information. So, there are four main types of neutralization reactions. You can mix a strong acid with a strong base, and that's most typically the type of neutralization reactions we've seen before. You can mix a strong acid with a weak base. You can mix a weak acid with a strong base, or you could mix a weak acid with a weak base. Okay? In all four of these, the general concept is the same. You're mixing an acid with a base, so pH is going to change, and accordingly, equilibrium is going to be affected. However, there are some small changes that are going to happen based on the strength of the molecules that are interacting. So, with a strong acid, strong base, this is an example of taking something like HCl plus NaOH. If these molecules react, you're going to make HCl plus, H2O plus NaCl. Notice I only drew a single arrow because these are both strong, so they're going to completely dissociate. There's no equilibrium here. So the net ionic equation would be something like so. This would be the net ionic, which I'm going to abbreviate N.I, net ionic. Okay? So these are the type of reactions that we've seen before, where usually, if the concentration, so the concentrations of these, concentration of HCl equals concentration of NaOH, and you have equal volumes, the final pH comes out to being 7, being neutral. Okay? Not always the case, because we could change the concentration or change the volume, but that's one type of reaction. Okay? With a strong acid and a weak base, in general, the final pH is going to be less than 7. And the reason for that is because you're mixing a strong acid with a weak base. So essentially, as the H pluses and the OH minuses react, you're going to run out of OH minus because you have a weak base before you run out of the strong acid. You're going to have more hydrogen ions around. And if you have more hydrogen ions, we know that's going to make a pH that's less than 7. With a weak acid and a strong base, the pH in general is going to be greater than 7 after they mix. Because it's for the same reason, but in the opposite direction. Once these guys are interacting to form water, which we know is neutral, eventually, since the weak acid is going to run out of hydrogen ions before you run out of hydroxides, OH. So there's going to be leftover OH minus at the end. And if there's leftover OH minus, that means the solution is basic, which means that a pH that's greater than 7. Weak acids and weak bases are a special case where the pH you can't predict necessarily. It depends on volume and concentration. Similar to, remember brackets mean concentration, similar to the strong acid and strong base mixtures. So what type of problems do we need to do with these? We need to do example problems like this, where we're given an acid and a base mixed together and we're asked to calculate the final pH. So in this problem, we're given 35 milliliters of a 1.5 molar HCN solution. I'm going to label this as an acid. That's just going to help me annotate the problem. Mixed with 25 milliliters of a 2.5 molar KOH solution. Here's my base. I need to know the final pH. Okay, so to get pH, remember that's negative log of H+. So I need to figure out how much H+ is going to be around after these things interact. I could also figure out the negative log of OH minus. That would give me the POH. And then from there, I know if I subtract that from 14, it will be equal to my pH. So what's important? How do I do this? Well, the first thing you're going to want to do is write a reaction. So write the equation, HCN plus KOH. Now you got to think about the products. Okay? KOH is a strong base, HCN is a weak acid. So you know that the final pH should probably be greater than 7. You also know it's going to be at equilibrium because they're both not strong acids and bases. So I'm going to make water, H2O, and a salt, in this case K and CN, KCN. So first thing, write your reaction. Second step, like we said before, here, the H pluses and the OH minuses are going to react to form water. So in order to figure out how much water we're going to make, we need to know how much H plus and how much OH minus we have. So to do that, I need to figure out the moles. So step 2, figure out the moles of each. So moles of HCN, okay? Well, I know volume, I'm going to change this back to purple, okay? HCN. Volume is 35 milliliters, molarity is moles per liter. So I got to convert this into liters. Divide by 1,000. So I have 0.035 liters. To convert to moles, I know it's 1.5 mole in 1 liter. That's from over here. So that's going to be equal to, if I do the math, 0.052 moles of H plus. Technically, it's the moles of HCN, but when this dissociates, it's going to make 0.052 moles of H and 0.052 moles of Cn minus. Now I need the moles of base. So same idea for the KOH now. My volume was 25 milliliters. Convert to liters by dividing by 1,000. And I know the concentration is 2.5 moles per 1 liter. So this is liters, those cancel. I'm left with, when I do the math, 0.062 moles of OH. So now I got to think about what's going to be left. I'm going to connect this back to ice tables. You don't necessarily need to, but it might be a helpful way for you to think about it because we've been getting a lot of practice with ice tables lately. So my initial concentration, I'm going to now use the phrase moles. The initial moles of HCN was 0.052. And the initial moles of KOH is 0.062. Before they react, I haven't made anything. Once they react, all of the acid and base is going to react until one of them gets used up completely. So you need to figure out which is going to get used up. Well, it's just like a limiting reactant problem. The one that's going to get used up is the one that you have fewer moles of. In this case, your H plus. So I'm going to lose, not X, I know I'm going to lose all of it. It's all going to react. Okay? So since the ratio of this is 1 mole to 1 mole, for every 0.052 moles of H plus that react, the same amount of OH minus is going to react. So I'm going to lose 0.052 moles of OH. Okay? That means, well, water's a liquid, so it doesn't really matter. I'm going to make 0.052 moles of KCN, coefficient of 1. But this doesn't really matter. This isn't going to affect the pH. What I care about is what's going to be left over out of the H plus and the OH minus. Well, there's going to be no H plus left over because 0.52 minus 0.052 is 0. What about the OH? Is any OH going to be left over? Yup. It's in excess. I'm going to have 0.01 moles of OH. Okay, well, what can I do with that? I need to get the final pH. So I have OH, so that means I'm probably going to need to calculate the POH. POH is negative log of OH minus concentration. I don't have concentration yet, I just have moles. So to get concentration, it's moles per liter. 0.01 moles, but now this is a trick. You got to think, how many liters do I have? What is the volume? Well, I mixed two things together. So the volume is not going to be 0.035, and it's not going to be 0.025. It's actually going to be both of those added together, because that's the total volume after the two substances were mixed. So the concentration would be 0.01 over 0.06, which is going to come out to some value. A value of 0.17. So that's the concentration of OH. So if I plug it in, negative log of 0.17, I get a value of 0.76. That's my pOH. So I know that pH plus pOH is 14. So since pH plus pOH is 14, if I plug in this value here, I would get a final answer of the pH equal to 13.24. Done. So, things to keep in mind when you're doing a neutralization problem. First step, I'm going to highlight all the steps in green here. First step, you might want to summarize these. Write the reaction. Second step, get the moles of each compound. Third step, okay, basically figure out what's left. Is there going to be OH or H plus left? Then from there, step 4, don't forget, convert to molarity using the total volume. That's a mistake that a lot of students make. And then finally, 5, calculate the pH using whatever you have left over. You didn't necessarily need to do an ice table here because if you just recognize that you have more base than acid, all you really needed to do is get the difference of these two numbers, which is 0.01, and then recognize that that's the moles of OH because that's what you have excess of. And then from there, do the same thing. Divide it by the volume, negative log of that to get the pOH, and then subtract from 14.